Let's now talk about the DOLS. What is DOLS? DOLS stands for Dynamic Ordinary Least Square. DOLS is a statistical technique used in econometrics for estimating the parameters of a model when the variables are non-stationary or integrated of order 1, that's in the nature of 1 bracket 1. Then DOLS is particularly useful in the presence of co-integrated variables, where a long-run relationship exists between the variables, but short-term dynamics also play a role. DOLS is employed in research data analysis when researchers are interested in estimating the long-run relationship between variables while taking into account any potential short-term dynamics. By using DOLS, researchers can address the issue of spurious regression that may arise when working with non-stationary variables. I repeat this. By using DOLS, researchers can address the issue of spurious regression that can arise when working with non-stationary variables. The DOLS estimation method involves transforming the variables to make them stationary, estimating the parameters using ordinary least squares, and then detrending the variables to obtain consistent estimates. This approach allows researchers to analyze the long-run equilibrium relationship between variables while controlling for any short-term fluctuations. So this is a very interesting one. Now let us see how we can do this, practically. We use the same data set that we have used before for this. Now let us see how this is done. And we also look at okay. Now let's see. Now this is the form. As usual, we have the dependent variable. Well, let's still call it meal, and then the independent variables, we use the same that we used before. You can start with any one. SAL, SES, EGG, ing 3, ing 1, ing 2, and I think do you still have any other one there? We have oil, yeah, oil. So let's check and see what you have. Oil, ing 2, ing 1, ing 3, egg, SES, and SAL. Good. You can see that all of them are separated with just comma, nothing else, comma only, like before. That's what is there. So in this case too, the time interval variables are also deactivated or disabled, while the variable groups are also disabled. Now we enter the data set name, the same data set name that we entered before. You say SUMTAS. That's the name, and we simply click use Excel file, and Because yeah, so it has already given us one of our plots. This is the box plot. The box plot for it, you can see. Look at it very well. You can see all these ones represent the variable that we used. Okay, and then I will click this one out. Yeah, it now gives another one. The line plot. Anyway, this line plot was done. Okay, this is the bar chart. That line plot was plotted, zigzagly, and that is why it was like that. So now this is the correct one. If you see, this one just measured the ingredients that were used in making the meal the way they are. Yeah, so that's that. And then of course that's all. Now let us now go to the result proper. Yeah, that is the data used, and then this is the DOLS summary. You can see the dependent variable is meal. So the model uses OLS, and then method is least square, and it's non-robust. Here you also have the R squared, adjusted R squared, the AIC and BIC criterion, and then you now come here for the parameter estimates. As usual, the coefficient is there, standard error, and many more. Yeah, so in this one, let's look at the probability. Is also just the same with that of the ARDL, and even the confidence interval, the upper and lower confidence interval are the same thing. And also it's even with the T statistics. Now the probability values, the omnibus, just like the other one too, and exactly what the conditional number is also there, and the same what you noted in the DL or ARDL is also what is noting here. Here I said the standard errors assume that the covariance matrix of the errors is correctly specified, and then the second condition said the condition number is large. This might indicate that there are strong multicollinearity or other numerical problems. Now these are other estimations from here. Yeah, you have the test statistics, which shows minus 6.368 positive for, and then the p-value is 0.00, which means that it is the t statistics is very, very significant. Then you see the Bridge-Pagan test statistics here. This one, the Bridge-Pagan test statistics revealed 6.550 and so on and so forth. Then the p-value is 0.477, which is quite higher than our 0.05, which is what we use. And you can see the variance inflation factors that almost all they have all the independent variables have very low VIF, except the constant, which has 1000 and so on and so forth. And then it is also telling us that the printable results are contained in C value stats, DOLS reg, and so on and so forth. So that is about this one. Supposing we want to check out whether what is telling us here is the correct thing. Now let us look at that value stat. Let's look at that value stat folder and see. Okay, that's the value stat there. We click open, and then okay, this is this is the bar chart of the DOL. That is the one it saved for us. Yeah, that's it there. And we click it up, and then this is the box plot. Same thing that you saved for us. Okay. Now, and then the DOLS main result is here. So I'll click it open. Yeah, so that's it. That's the result there. What we have there is also what we have here. So that is the user can then print this one to support the analysis, the report. So that's it, and that's about the ORDL. That's about the ORDL. Dynamic, DOLS, the dynamic